Welcome back to Geometry Summer Prep. We are looking at lesson 9 today, all over polygons. So up until this point, we have looked at a very specific polygon, triangles. We've looked at some triangles problems. We've also looked at circles. So we're into a new unit now that we haven't covered, some different shapes here. So let's first define what a polygon is, and then we'll talk about some of the stuff down here. So go ahead and fill this in. This is saying that a polygon is a closed figure, formed by 3 or more line segments that we call sides. Okay, so biggest takeaway here is it says it's a closed figure, so it can't be something. I could show you what is not a polygon. It would be like, let's say you had something like that with this like gap right here. That would not represent a polygon. Also, a circle would not be a polygon, okay? Because notice that in the definition, it has to be formed by 3 or more line segments. Okay, so that's why we have a whole separate unit just for circles. All right, so we know what a polygon is. What do we need to know about polygons? Well, a couple of the biggest things you guys are going to be asked to find is the interior angles of polygons, and if I go to this page, the exterior angles of polygons. So this looks like a lot of notes. The practice sheet is actually pretty short, and the notes, I will say, they formally start down here with a formula, okay? And I was thinking, I'm like, well, I could just give you this formula and start the whole thing right here, but I really want this formula to make sense to you, like why that formula is the way it is, because it is a very logical, kind of intuitive formula. And so I'm going to show you how we get that formula by looking at like a little chart up here. And we'll only fill out a little bit of it. I know this looks very extensive. Once you see kind of this part of it, you'll notice a pattern, and we probably won't have to do the rest of it here. So before jumping straight into it, take a look at some of these words over here. And some of them may look familiar. Maybe all of them look familiar. You've probably learned most of these words at some point. And when you're in geometry this upcoming year, you're going to need to memorize all of these. There might even be a couple more that your teacher gives you. Let's look at this real quick. So these are all the names of the polygons that we're going to work with, starting from the smallest one, like based on number of sides, which would be a triangle. A triangle has 3 sides, a quadrilateral has 4 sides, a pentagon is 5, hexagon is 6, heptagon is 7, but I will say there is another word for heptagon that some teachers might choose to use if you want to take a little note of that. That's the same as a septagon. Septagon. So it has 2 words. I just chose to go with heptagon, but there you go, FYI. Then 8 sides is an octagon. This is usually one that's very new to kids. 9 sides is known as a nonagon. That might be a brand new one. And then 10 sides is a decagon. And that's all we are going to go over. There's like a couple after that, 11 and 12. But I want to make sure you guys have these 10 down. Okay. So let's read through this right up here. Now it's talking about the sum of the interior angle measures of a polygon. Over here it says, the sum of the measures of the interior angles in any polygon can be determined by the number of triangles that can be drawn within the polygon. Interesting, okay. It says to complete the table below and look for a pattern to find the sum of the degrees in any polygon. So we are going to base all of this off of what we know about a triangle. Let's zoom in a little bit to this top part. So they give us a picture of a triangle. Let's fill out this part for a triangle. We know the number of sides of any triangle is 3. Now it says number of triangles. Well, in here, this is just one triangle. So I would say there's one triangle in a triangle, okay? And then the sum of the interior angles, we learned this a while back. When it says the sum of the interior angles, it means what's this plus this equal in any triangle. And if you remember, that is 180 degrees always. So basically what we want to do is divide all of the other polygons into how many triangles are within it, and use our knowledge of triangles to figure out what the sum total of the interior angles would be for that polygon. So let's look at the next one. Okay, next one is a four-sided figure right here, known as a quadrilateral. So I'll say it has four sides. Now it says the number of triangles. So it's basically asking you how many triangles could you put in this quadrilateral, and they've kind of like sketched it out for you with the dotted lines. And you may be asking yourself, well, I could draw a lot of triangles. I could draw, that would be like two triangles, right? 1, 2. But you might also be thinking like, well, I could also go like this, and now I have 1, 2, 3, 4 triangles. And you can maybe even be like, oh, I can even like draw more triangles, like going like that, right? So when we say how many triangles, you're kind of thinking like minimum amount. And specifically pick one vertex or one corner and draw as many diagonal lines to other corners as you can. In this case, there's only one diagonal line that can be drawn, right? I can't draw a line from here to here. That's not going to form anything but the side of the figure. So pick a corner and draw however many lines you can to the other vertices. That's how you determine the number of triangles. In this case, we would say there's 2 of them. So for any quadrilateral, I can kind of cut it in half and make 2 triangles. So what would be the sum of the interior angles of this quadrilateral? Well, think about it. If each triangle has 180 degrees, then you've got one there and you've got one here. So you can add them together. So the sum total would be 360 degrees. Follow how we're doing that? Okay, let's try the next one. So this next one is a pentagon. That's a 5-sided figure. So number of sides is 5. And how many triangles could be formed? So if we zoom in, they picked this vertex and kind of did a little line to this one and then to this one, and that's all you can do. So we have 1, 2, 3 triangles drawn. So number of triangles would be 3. And then we know there's 180 degrees in each one. So to figure out the sum of the interior angles, you're going to do 180 times 3 in this case, which would give us 540 degrees. And I should have said in the beginning, you're for sure going to want to use a calculator in this section. There's going to be some big numbers the further we get here. Okay, next one, you might already kind of see the pattern here. Next is a hexagon, which number of sides would be 6. As you can tell, we're just increasing by 1 each time right here. Number of triangles formed, you could maybe figure out how many it's going to be, but let's double check. From here, we would draw lines this way, and this way to all the corners, creating 1, 2, 3, 4 triangles. And we know there's 180 per each triangle, so we're going to do 4 times 180, which is going to give us 720 degrees. And you could see that you could keep doing this forever and ever. So let's not worry about the rest of it. I think you probably get the idea here. And let's go ahead and fill in our formula, and hopefully this makes a little bit of sense to you based on what we looked at. So the interior angle sum formula. Now it says if n represents the number of sides of a polygon, then the sum of the interior angles s, let's put s equals, the total sum equals, it can be found using the formula. So the formula is you take the number of sides of the polygon, I'm going to put it in parentheses, and take a look up here with what happens. All these number of sides and compare them to the number of triangles. Do you notice this one is always 2 less than the number of sides, right? 2 less. So what we do is we take the number of sides and we subtract 2 from it. Now that represents right there how many triangles are in the figure, and we multiply that by 180 degrees. I'll just put 180. And that is a formula you can use for any polygon to find the total sum of the interior angles. So let's try some actual examples with that now. And this is going to be a big calculator section. So maybe work through the first one with me and then pause it and try the others just to check your work. So it says, find the sum of the measures of the interior angles in each polygon. Now, if you notice, these are bigger numbers, and you won't be expected to know the actual name of a figure that has 15 sides. So past 10, like a decagon, or 12, they're just going to ask you to write it like this. If it has 15 sides, we'll call it a 15-gon. If it has 21 sides, we'll call it a 21-gon, and etc. All right, so if we know it's a 15gon, it has 15 sides, that means we're going to plug that 15 in for n in the formula, okay? So we would be doing 15 and subtracting 2, which would be 13, right? So that means there's 13 triangles in a 15gon, and we multiply that number by 180. So calculator work, if you want, you could type it in just like that. Make sure you put parentheses around this if you do, or just shorten it and make that just 13 times 180. And it looks like we're going to get 2,340, and I would make sure you put the degree symbol there. So that would be the sum total degrees of the interior angles of a 15gon. So maybe pause it and try the others. Let's go through this. So for a 21gon, same process. I'm going to take 21 and subtract 2 and multiply that by 180. So I'm really doing 19 times 180 here. Calculator work, that's going to give us 3,420 degrees. And a couple more, but it's all the same process. 48gon, we're going to take 48. That's how many sides there are. Subtract 2, so that represents the number of triangles, times 180. And if we do that, that's going to give us a grand total of 8,280 degrees. Okay, and last one, hopefully you've done all of this by now and you're just checking your work. We are going to do 36 minus 2 times 180, which will give us a grand total of 6,120 degrees. Okay, so that's how you use that formula. Not too bad. Let's look at another part of this. Let's look at just this part. This kind of goes along with the other page. And if you want to pause after this and go try some of the practice problems, that's a good idea to kind of break this up. And then this part is going to be the remaining part of it, which talks about just the exterior angles, which I personally think is the easier part. So we're getting the harder part out of the way, which really isn't too bad either. Okay. In order to jump into these next two little practice problems, we need to define what a regular polygon is. So we just defined what a polygon is. Let's talk about what it means for it to be regular. Go ahead and jot down the definition. It's pretty simple. It's a polygon with all sides congruent and all angles congruent. So think about that for a minute. If I sketch this off to the side, let's say I have a quadrilateral. Let me just draw something like this off to the side. Okay, I filled it in, that's fine. That would be a quadrilateral, right? A quadrilateral just means it's a figure with 4 sides. Doesn't say anything about them, just a 4-sided figure. So this polygon would not be considered a regular polygon because all the 4 sides are different lengths. It looks like maybe these two are the same and these two are the same, but different lengths. And like this is a bigger angle and this is a smaller angle, right? So this would not be considered a regular quadrilateral or a regular polygon. But think about like a quadrilateral you could draw that would be considered regular. All its sides are congruent and all its angles are congruent. You actually know what this is. This would be a square. If I can do this. Okay, close enough. A square would be an example of a regular quadrilateral because all 4 sides are congruent and all 4 angles are congruent. So to do this next part, it only works if the polygon is regular. If it's not regular, you'll have to do it a different way. Let me jump over to the practice sheet real quick. Oh wait, I think I have it all filled out. That's okay, I can clear that. Let me just show you this real quick. Numbers 9 and 10, when you get to those are polygons, but they are not regular. They are irregular. So when you solve them, you're going to have to go about it a different way, which I want y'all to try on your own, but I'll definitely have the solutions in the video too, which there they are. Okay, let's take a look at this last little part of the interior angles. So it says, the measure of a single interior angle in a regular polygon, I'm going to underline that, a single interior angle, can be found by dividing the sum of the interior angle measures S by the number of sides N. So on the previous page, we were concerned about finding the sum total of the angles. Now they want you to find the measure of just one of them, each interior angle, okay? And if you think about that, if it's a regular figure, you can take the sum total, like if you look at this quadrilateral, I know for a quadrilateral, the sum total is 360 degrees. And if I just divide that by 4, because there's 4 sides and also 4 angles, that'll give me 90 degrees, which would be exactly each angle measure. Okay, that wouldn't work for something like this. The sum total is 360 degrees, but if I just divide it by 4, that's not going to be representative of all the angles because they're all different. Okay, so as long as you're working with regular polygons, you can do it this way. So let's solve number 5. Okay, they give me a regular pentagon. So first I would want to find the sum total of the interior angles. Now pentagon, this is when you got to be good with your vocab, that means we have 5 sides. So in the formula, I'm going to take 5 minus 2 and multiply that by 180. And I'm going to make a little adjustment since we're finding just one of the interior angles. It says find the measure of each one of them. Add one more thing to this formula. We're going to go divided by the total number of sides. So you're going to divide by 5 in the end. And that's how you'll handle finding just one of the angles. Okay, so let's do that. So up top, we're doing 5 minus 2, which is just 3. So up top, you're doing 3 times 180 and then dividing that by 5. So if you want to get your calculator and do that, let's see what you get. That ends up being, what is that, 540 for the pentagon divided by 5. So we end up with 108 degrees. And that would give you just one of those angles. So let's try it for a regular 18gon. So again, let's start with finding the sum total. So we're going to do 18 minus 2, multiply that by 180. But we know we're trying to find just one of the interior angles, so make sure you divide it all by 18 in the end. Okay, I'll let you do that calculator work. If you want to pause it, I'm going to pop out the answer. You should get 160 degrees in the end. All right, that covers everything you need to know about interior angles for now. I do have I think one bonus problem over them that you can try, and if you have a hard time with it, then that's okay. We'll go over it in the practice video. All right, let's go ahead, if you're ready, to jump into exterior angles, which I personally think are the easiest ones. So these figures all look kind of funny, right? Because they have exterior angles drawn. So just to refresh your memory on that, we did talk about them a little bit in one section. If you have a polygon, like we have a triangle here, and you just extend one of those sides further to the outside, you create an exterior angle, okay? So like here's a side drawn this way, so we created an exterior angle. And you could have drawn it like so many ways. I could have extended this side this direction and created an exterior angle right here, okay? So now we want to shift our focus and figure out what the sum total of all of those exterior angles would have to equal. And we're going to test it out for a triangle, a quadrilateral, a pentagon, and hexagon, and see if we can make some conclusion down here. All right, so this is kind of wordy. If you know your vocab really well, it makes sense. It says exterior angles are supplementary to their adjacent interior angle. Let me explain that part. It is just saying if you have an exterior angle, the way you would figure out what this one angle equals is, well, since it's supplementary, because you've got a straight line here, it's supplementary with this angle that's next to it. So if I said find just this angle, you would just do 180, right, supplementary, minus the interior angle next to it. In fact, I want you to do that right now. 180 minus the 61 to find this degree out here. And you should get 19 degrees. And I want you to find all of them, and that's how you'll do all of these exterior angles. You're just going to take 180 and subtract the angle that's on the inside right next to the exterior angle, because those will always be supplementary because they're on a straight line. So that's what that top little sentence was saying right there. Now it says find the measure of each exterior angle on the polygons below, then give the sum of all the exterior angle measures. So let's go ahead and find all 3 exterior angles. So this one's 19. If you do 180 minus 79, you get 101 degrees. And over here, you do 180 minus 40 to get this one, so that'd be what, 140? And now, add them all together. So this is a lot of calculator work. This plus this plus this. Take a second to do that. Add them together. You should get a grand total of 360 degrees. Okay, so that's the sum of the exterior angles for a triangle. Let's test it out for a quadrilateral. Okay, so same thing. We're going to go to each of the 4, because it's a quadrilateral. It means 4 sides, which also means 4 exterior angles. Let's find each individual one. So you're going to do 180 minus 71 right here. So that would be 109 degrees. Let's go over here. Let's do 180 minus 124. That's going to give us 56 degrees. Keep going with that if you want to pause this and then check it. So then we've got 180 minus 76 degrees. We got 104. And then over here, 180 minus 89 degrees. That's going to give me 91 degrees. All right, once you have all those, add the 4 together. Maybe pause and do it, because I'm going to answer it pretty quickly. And you notice something kind of interesting. If you did it correctly, you should get 360 degrees. Weird. So we know they add to 360 for a triangle and a quadrilateral. Let's see what happens with a pentagon. So maybe pause and do this. I'm going to go through this one pretty quickly here. So some calculator work, do the same thing. You should get, I think this is 82 degrees. Over here you should get 59 degrees. Remember, I'm just doing 180 minus all these numbers. 93 degrees, 50 degrees. Double checking all of those. I think that's right. And then 76 degrees for the last one. Okay, if you have added all of them together, something crazy is happening. You notice you get another 360 degrees. Interesting. Do you think we even need to do the last one? I don't think we do. So I'm going to go ahead and spoiler alert here. For a hexagon, the same thing's going to happen. What do you think happens for an octagon or a nonagon or a decagon? The same exact thing will always happen. And that's why exterior angles are so much easier, because you don't have to memorize a formula. You know, no matter what polygon it is, and this works for regular and irregular, all of the exterior angles will add to 360 degrees every single time. So let's fill that in over here. It says, what can you conclude about the sum of the exterior angle measures of a polygon? I'm going to shorthand this and say they all equal 360. 360 degrees. There you go. Okay, so let's see if we can use that to answer a few questions down here. Now, these are a little bit different, but they're still pretty simple. So number 7 says, what is the measure of, uh-oh, my mic fell. Hopefully y'all can hear me. What is the measure of each exterior angle of a regular hexagon? Okay, so it's not asking the sum total. We know the sum total is 360. How would you find just one of them, you think? I guess I could draw a hexagon, but that's not necessary. Okay, it's going to be this simple. Take the sum total, 360 degrees, and if you divide that by, I'm going to call it n, the number of sides, that will give you just one of those exterior angles. So in this case, we're simply going to do 360 divided by, well, how many sides do we have? It's a regular hexagon, so this is where you're really going to have to know your vocab. So you're going to divide by 6, which will give us just 60 degrees. Okay, so 60 degrees would be each individual exterior angle. Okay, number 8, what is the measure of each exterior angle of a regular 24gon? Well, you get the drill here. You take the sum total, 360 degrees, divide by 24 sides, which is still also 24 angles. And that's going to give us 15 degrees per each exterior angle. Okay, 9 and 10 are slightly different, but they're done in almost the exact same way, y'all. So number 9 says, if the exterior angle of a regular polygon measures 12 degrees, how many sides does the polygon have? So they're giving you one of the exterior angles here, and they want you to figure out how many sides that would be. You can actually do this in the exact same way. If you know they add up to 360 degrees, and you divide by just one of those exterior angles, so one of the 12 degrees, however many times that goes into 360 will tell you how many angles that there are, which is the same as how many sides that there are. So we're just going to do 360 divided by 12, which gives me 30. And I'm not going to put a degree on it because this is the number of sides that the polygon would have to have. 30 sides. Okay? Same over here. If the exterior angle of a regular polygon measures 40 degrees, how many sides does it have? We'll take the grand total, 360 degrees, divided by just one of those angles, 40 degrees, and that's going to give us 9 sides. So this would be a nonagon, 9-sided figure. All right, that is it for that. Let me look back here. Yeah, if you want to hop over to the practice problems, I will show you there which ones are considered bonus. Otherwise, dive in and just try to do all of them and then see how you do. All right, I'll see you guys on the next video.